This is SeongJun. I'm a professor at Korea University, but I think more about today's talk is about the representative of Republic of Korea for ITR meeting, especially for Working Party 5D. We heard a lot of great news and great effort by the great research in all over the world yesterday and today. And so I'm going to talk about the one report that is published. Actually, it's not published yet, but it will be published by the end of this month. ITR has working on the generation of IMT system, starting from the 3G, 4G, and 5G, and now we are working on the 6G, which is called the IMT. It's called the IMT system toward 2030 and beyond. And so last June, there was a report finished that talks about the future technology trend, and it's also about the terrestrial IMT system. This is the, it can be called as the 6G, but we have to be careful. This is the scope is limited to the terrestrial part, and also it's not the whole entire network, the radio access network. So you can see the photo in my slide, which is the which I've been taken the June meeting on Working Party 5D in Geneva. Okay. So last June, there was a lot of things has happened in the Working Party 5D meeting in the June, and then their important milestone has been finished, reached at that meeting. And I'm going to show you the 6G timeline that has been finished, and also a future technical trend report is finished, that which I'm going to introduce today. And also there was a lot of discussion on the 6G and the vision, 6G vision workshop has been held. And also we talk about the new frequency spectrum, which is about the above 100 gigahertz. That report is on progress. So it's keep working on the current meeting, which was the last month. There was also meeting, October meeting, and it's keep going on. So, and also there was some press release from the current government about the progress on the FTT. So, all right. So I'm going to give you a brief overview of what's going to happen in the ITR in perspective of 6G. So we are at the 2002, which is around here. I'm not sure if you can see my the laser beam, but we are 2022, and you can see the ITR report on the future technology trend has been finished as of June, and some other vision work and then other 100 gigahertz report work is ongoing. But you can see that at the last week, which is 2030, the IMT 2030 specification will be finished, which is called the 6G technology. And also there's the WRC 23 and 27. They will talk about the frequency spectrum, not only for the 6G, but also all entire the frequency spectrum. And the ITR is working on the cycles of the WRC. And we can see that there are three phases of the standardization. So, before working, WRC 23 is the first phase. We're talking about the future technology, and we're talking about the vision, and the specific number or technical specification or technical requirement and evaluation methodology will be decided between WRC 23 and WRC 27, which is the second phase. And after that, the 6G technology, IMT 2030, IMT maybe called IMT 2030, will be finalized at the year 2030. There is also submission and evaluation and consensus building. That these types of timeline has been the case for the 5G, 4G, and even 3G. So today I'm going to talk about is the what's the future technology trend that has been a report finished by ITR last June. Okay, so you can see also where we are the whole entire about 10 years of the process of the standardization. Okay, so future technology report, which is also called FTT report, it consists of 45 pages of report that all talk about the future technology for IMT system, but it's also it's limited to the terrestrial part. And also the 45 pages of report does not have any figures, it's all text. So it's kind of a boring, and in somehow it's a kind of a dry in some sense. So that's why I have a talk here to give you some idea what is that and what part we need to focus. Basically, it consists of three main parts. The first part is enabling technology trends and enabler. So I listed all the component technology under the enabling technology. You can see in the left part of my slide. And also, there are two other sections. One is for the radio interface, and the other one is the radio access network. So it proposed some new technologies and several new technologies, including starting with the AI and integrated sensing and communication. And also another section is for the radio interface. And also the other section is for the radio access network. So you can see enabling technologies and radio interface and also radio network part, okay? So after about 2 years of effort, there are a lot of contribution from many member states of the ITUR. There are several meetings, and then similar things are merged, and some out of scopes are deleted. And after many years, many months of effort, the report is finalized, and see what's the key idea and what's the key technology that we need to focus on. Okay, all right. First part is AI, the artificial intelligence. It's mostly machine learning type ML. And there are a lot of pages, I think it's about 4 or 5 pages are assigned for this AI technology. So AI is definitely an enabling technology for IMT system for 2030 and beyond. But if you think about AI for the 6G, and we can think about two different perspectives. The first perspective is AI technique will be adopted by IMT system to improve its performance. It means that IMT system will make use of the tool provided by AI and ML. So how can AI and ML technology be applied? The first one is the radio part, radio interface part, the channel estimation, receiver algorithm, and MIMO algorithm. So I'm not quite optimistic about the channel estimation part, but the receiver algorithm and then MIMO algorithm, especially the beam selections, we can make use of the big data and the AI and machine learning algorithm to select the beam in optimum sense. So that's the improvement in the radio interface by making use of the AI ML technology. The other aspect is to improve the IMT network, especially the radio access network. So radio access network and even core network, the main problem in the network is to efficient use of network resources. So AI ML they are tool to provide a better solution for the optimization. So the resource allocation issues in the RAN and the IMT system core can be well fitted to make use of the AI technology. So the first bullet is AI can help the IM system to improve its performance. So 6G will be improved thanks to the AI ML technology. That's the first case. The second case is the other one. IMT system will support to AI and ML application. So AI and ML relies on a lot of data exchange. So a lot of data exchange, and that the data is used to training the model, and there must be a lot of data exchange. And so large volume of data exchange, the IMT system will help. So, and also the network will evolve such that from cloud edge of the network, even mobile devices. So AI, ML, the technology will be will make use of the IMT system. So IMT system will support those applications. So we can think about in a bigger sense, the AI technology and IMT technology will go together by helping each other. But we need to see two different aspects for the AI. Okay. Next one is sensing. Okay, so sensing is I was really, confused what sensing mean. I thought about wireless sensor network or something like that, but it's a little bit different concept. So IMT system will consider sensing functionality in addition to communication functionality. It's a big change. And actually, after this report is finished, Working Party 5D ITR is working on the 6G vision. And use cases, usage scenarios are discussed, and sensing is one of them. And I think that main idea of the sensing is it's beyond the communication. So beyond communication means that in a simple word, we have a base station and we have smartphones. They're used mainly for the communication, but those devices and the network can be used for other purpose, something like the positioning, something like the object detection, ranging, tracking, imaging. So these are functionality that the network devices or even a smartphone can provide. So the communication infrastructure, which is made mainly for the 6G application, but that also provide other than communication functionality. So that's the big application or use cases in the 6G, so which is kind of a beyond communication. That's one nice thing that we need to focus on, which is sensing. The other technology that we can think about is convergence of communication and computing. It's quite, can be very easy concept, but it's also very kind of complicated. Why? Because in many use cases, heavy computing and high data rate come together, especially like the digital twins and the cyber physical systems and the industrial and service robots. So therefore, that means we have a lot of data and also a lot of computation. So the computation load can be moved to the edge of the network, which is called the mobile edge computing. And also the smartphone is nowadays has a high computing capability. So some computation can also be conducted in even mobile devices, not only the network. So which is called a dynamic workload distribution, but it's quite challenging work that which include some scalability issue and some data collection issue and synchronization and management. So we can think about from 6G, the communication and computing are kind of integrated, or some people call it a joint, and it may be difficult to find a clear cut between the computing and communication. So the merging of these two technology is also a new technological trend toward the 6G, okay? So I think that the AI and the sensing and also the convergence communication and computing are distinct futures, what was not observed in the previous generation of IMT system. That's what I can see here. And not only that, there's other important enabling technology like the sustainability. So sustainability is, to me, it's kind of a low energy communication, including the backscattering communication and on-demand access. So low energy has been an important issue even for the previous generation of YMT system. But now we are talking about the new technology like the backscattering communication and ambient energy harvesting or something like that. I'm not quite sure how is it realistic by year 2030, but those are technology the people are working on. And trustworthiness. So we also talk about the importance of the security and even the higher level of security we call the trustworthiness. But there are still the debate what does trustworthiness in the IMT system. But there's definitely an effort in many researchers about how to improve the RAN privacy. And also we also consider the physical layer security in IMT system. So also there's a real-time communication technique, like some synchronization techniques are also studied there. And also there are spectrum. Spectrum is always important. And there's not much of a spectrum band in the middle band. So IMT system are considering the even higher frequency band. So something like the terahertz or sub-terahertz. But it's quite challenging. Not only in the propagation issue, but also the implementation of a digital device supporting the terahertz is also challenging. So there are also research on the terahertz. And in order to solve the scarcity issue of the spectrum, and they are also talking about some frequency sharing technology for the 6G system, but sharing is very sensitive issue, and there was a lot of debate on whether sharing is enabling technology or not. But anyway, there's a discussion on the sharing of spectrum. Okay, those are the some notable enabling technology that has been reported by ITUR. And also, let me show you some radio interface technology for 6G. Actually, for this section, there are 6 component technology, like the improved modulation and coding scheme and improved the multiple access, and advanced antenna technology. We call it the extreme MIMO. And also in-band full duplex. So we talk about the FDD and TDD, and it seems that the 5G is more about the TDD. And then even we want to improve the spectral efficiency by having the full duplex. In the in-band full duplex means that we have same transmitter and receiver are at the same time, same frequency, but we are trying to cancellate to have improved spectral efficiency. And we'll also talk about the RIS. I saw an interesting presentation before, and the terahertz component technology. I had already talked about that as enabling technology, and also talk about the positioning. And then they are targeting in the sentimental level for the radio interface technology. So these technologies are being researched actively for the future IMT system. Okay, this is my last slide. There are many radio access network improvement technology, RAN slicing and QoS support and RAN node cooperation and aggregation and user-centric architecture. And I saw a very interesting talk this morning about this user-centric network. And also there's an NTN, the satellite and HIPS and UAS. And this is, but it was discussed in this ITUR report in a very limited. Again, this report is for the terrestrial IMT system, and clearly this NTN is non-terrestrial, as the name indicate. So, but I'm pretty sure that the IMT 2030 or the IMT system for 2030 and beyond will have the terrestrial and non-terrestrial will interwork together and interconnect together. Okay, so that's what we can see to have a better coverage and for better connectivity. Okay, and also we talk about the ultra dense radio network deployment and also RAN infrastructure sharing. So there are interesting technologies are being researched in the radio access network, and also, as I previously said, some AI sensing and convergence of the computer and communication and all the other enabling technologies. So that's the report, very boring and dry explanation of technology in ITUR report, and my talk is to summarize those reports. Thank you.